Hey, what's going on, everybody? Mr. Cornell here, getting ready to dive right into teaching you the reciprocal of trig functions. Okay, so in order for us to do this, we have to understand, well, what is a reciprocal? Okay, reciprocal is like a multiplicative inverse. It's basically taking and flipping upside down, and your answer is always going to become 1. They basically cancel each other out. So what I'm assuming a lot of people know is, okay, all numbers are fraction. That's probably where you've used reciprocals before. So if I wanted to know the reciprocal of 8, we're going to flip 8, right? 8's a fraction because it's over 1, so it becomes 1 over 8. Now, if you're multiplying 8 over 1 times 1 over 8, you're just going to get 1. Okay, you can take reciprocals of numbers, okay, like 2 over 3 or even negative 2 over 3, and that becomes negative 3 over 2. And again, when multiplied together, it ends up giving you 1. You could take reciprocals of letters, right? So if I had 1 over A, I can just make it A over 1 or just A. So that's what a reciprocal is, right? But now when it comes to trig functions, it's the same concept, but not the same idea or the same answers, right? So before we get too deep into that, well, let's make sure we understand our trig functions. So you have sine, cosine, and tangent, and then each one of those has its own formula, and a lot of people like to use the acronym SOHCAHTOA to remember your formulas. Okay, so the sine function here is the opposite divided by the hypotenuse. So this is opposite divided by the hypotenuse. The cosine is AH, or the adjacent side, divided by the hypotenuse. And your tangent side is your opposite side divided by your adjacent side. Remember, this is all coming from your 90-degree right triangle. Okay? Now, when we're doing sine, cosine, tangent, and I want to know their reciprocals, they have new names now. Okay? So if I wanted to cosecant, is the reciprocal trig function of the sine function. Okay, the secant is the reciprocal of the cosine function. Okay, and the cotangent is the reciprocal function of tangent. Okay. A lot of people get confused. They want to call the cosecant from the cosine and the secant from the sine. I would too, but I didn't make this up. I just have to keep following the rules. So cosecant, the reciprocal from the sine. Okay. So if I wanted to know, and now here are their abbreviations, right? So cosecant, like cosine, we call it cos, right? Cosecant is CSC. Secant is SEC, and cotangent is COT. So take their reciprocals, flip it. So if the sine is O over H, then the cosecant is going to be H over O. The secant would be A over H. We're going to call it H over A. And then the cotangent would be A over O. So that's just basically flipping their formulas upside down, or then making their reciprocals. Now, there's another way that it could write it, remember, because we're making one. Cosecant is having 1 over sine theta. Not really necessary now, but it will be later on. Secant is 1 over cosine theta, and cotangent is 1 over tangent theta. Okay, so we're going to use that a little bit later on. So let's take a look at an example here. Find the value of all 6 trigonometric functions for angle A. Okay, so this part's important if you recall. So here we have a right triangle. The side opposite of your 90 degrees, remember, is considered your hypotenuse. The side opposite of the angle that they want to know is the opposite side. And then your final side is your adjacent side. So there's your labeling part. So now there are 6 trig functions. Okay, there's the sine function, which we said was opposite over hypotenuse. There's the cosine function, which is the adjacent over the hypotenuse. And then there's your tangent function, which is your opposite over adjacent. Then we have the cosecant, which is, now take his reciprocal, H over O. There is the secant, which is H over A. And then there's your cotangent, which is A over O. I forgot their thetas. Or actually, I shouldn't be writing theta at all. I actually should be writing A, because they're telling me to use angle A. Okay, but I could fix that by putting a theta right there. Okay. Problem I'm missing here. Okay, remember it's a right triangle. You can use a squared plus b squared equals c squared, our Pythagorean theorem. X squared plus 12 squared equals 13 squared. Or maybe you're just really familiar and really good and know that this is one of the triples and it is 5. So this missing side is just 5. Say 5, 12, 13 triangle. So now if I'm just going to go ahead and fill it in, the opposite side was 5, the hypotenuse was 13. Okay, that's why I labeled it. The adjacent side is 12, the hypotenuse is 13. The opposite side is 5, the adjacent side is 12. Okay, don't even have to read. I could just go ahead and flip 13 over 5, 13 over 12, and 12 over 5. Okay, remember I'm just kind of taking the reciprocal of the functions I already found. And there you go. That's how you're going to do these questions. All right. Next one. Okay, so here we go. I have absolutely nothing. It is a word problem, and they're going to have to ask me to find, again, all 6 trig functions. So let's go ahead and draw the picture of right triangle ABC. Our only important angle here is angle C, right? Because they told me that he is the 90 degrees. I don't care where you put A or B, okay? AB is 4, CB is 3. Okay, remember again, maybe you're pretty good, but this is going to be again a squared plus b squared equals c squared. Now this one's not as nice as the last one because it's not a triple. So you'll have 9 plus x squared equals, that's not 42, that's 4 squared. 16. So x squared is, make sure my math is good, 7. So here, I'm not even going to do any decimals. I'm going to leave them as square root 7. So now they want all 6 trig functions of angle B. Okay, so now you're using angle B. Sine of B, cosine of B, tangent of B, O over H, A over H, O over A. And again, SOHCA, TOA, sine OH, cosine AH, tangent OA. Then here you're going to have the cosecant of B, which is now flip it, H over O. Secant is H over A, and cotangent is A over O, and this is all of angle B. So now here we go. O, let's label. Opposite of the 90 is your H. Opposite of the angle that they gave you is O, and final side is A. So if I'm going to do this, I'm going to do radical 7 over 4. Here is going to be 3 over 4. And here is going to be radical 7 over 3. Flip everybody now. 4 over radical 7. 4 over 3. 3 over radical 7. Now, here's the thing. And we're going to do this actually in the next lesson, is called Rationalizing the Denominator, because we're not going to keep this radical 7 in the denominator. But for now, they said simplest radical form, which is there, so we're good for now. All right, so there's exercise 2. Going down to number 3. So now they're asking us to draw and label an appropriate right triangle based on what they gave me. So they gave me the sine, which is opposite divided by hypotenuse. So if I went and drew a right triangle, here is H. Now you're going to have to label your theta. It doesn't matter where you put your theta, but that will kind of affect where you put your O and your A. So make sure you label that. So the O is 7, the H is 11. There you go, done. Okay, cosine, same question. Here's my right triangle. Let's put theta up here now. Okay, here's the H. Since theta is there, this is going to be the opposite side, and this is going to be the adjacent side. So cosine is A over H. So the A is 5 and the H is 12. As long as I have this guy labeled, okay, doesn't matter if he's up here or down there, you're good to go, okay? Tangent is opposite over adjacent. We'll put theta right down here. So the opposite side is 7, the adjacent side is 6. Okay, if you want to give a pause, try your reciprocals down here, your cofunctions. Okay, so the cosecant comes from sine. Sine is O over H, so they're giving me H over O. Here's my right triangle. There's my theta. So this is my hypotenuse side. This is my opposite side, so it's 15 and 8. Remember, secant comes from cosine, which is AH, so we're going to do HA. Okay, so here's your theta. So then that means your H, your O, your A. So H is 14, A is 9. And then cotangent comes from tangent, which is O over A, so I'm going to do A over O. So here you go. There I am. O, H, and A. A is 16, O is 11, and that's labeling the triangles from them giving me the fraction. Okay? Okay, find the value of the trig function indicated. Okay, so they want the cosecant if I'm giving you the tangent. So when you're going to do these, it's kind of the same question, okay, as before, but now they're after doing and creating your triangle and putting everything in, they want to know the cosecant. So the tangent is the opposite divided by the adjacent. Cosecant comes from sine, so in order to find a cosecant of theta, I need to do the hypotenuse over the opposite. So I don't have the hypotenuse. So just here's a visual for you. There's your H, O, and A. So the O is 5, the A is 12. You're either good at this and you know your triples are 5, 12, 13 here, or maybe you're not, okay? And you just do 5 squared plus 12 squared equals x squared, and you'll get your 13 that way. So the hypotenuse here is 13, and your opposite is 5. And there's your cosecant theta. Okay, so now here they're giving me the cosecant to be 1.75. Easiest thing to do, put 1.75 in your calculator, hit math, enter, enter, and then that's just going to give you 7 over 4. So we're creating the fraction from the decimal, okay? So what they gave me was cosecant theta is 7 over 4. They want the cosine of theta, which is adjacent over hypotenuse. Cosecant comes from sine, which is H over O. Here it is, theta, so the H is 7 and the O is 4, okay? So this one is not a triple, so I'm going to have to do this Pythagorean theorem. And 4 squared plus x squared equals 7 squared, okay? I'm going to do 16 plus x squared equals 49, which means x squared is 33, so this here is square root 33. So the adjacent is the square root of 33. Your hypotenuse is 7. Okay. Okay, and our next one, find the other 5 trig. So same as the last, except now they're giving you the cosecant, but they want all the rest of them. Okay, they want the sine, they want the cosine, they want the tangent. They gave me the cosecant already. So then they want the secant and they want the cotangent. So maybe try to give it a pause, try it yourself. Okay. So the cosecant we can see comes from sine, so that's going to be H over O. So your H goes here. you're O, so that means you're 7 and you're 6. So you're going to have to go ahead and find the A with 6 squared plus x squared equals 7 squared, and you're going to end up here with the square root of 13. Okay, and then you go and plug it in. So sine theta, O over H is going to be 6 over 7. Cosine theta is A over H, which is square root of 13 over 7. Tangent is O over A, which is going to be 6 over square root 13. And then you can just go and flip here. You don't have to go back and check. There you go there. And again, there's rationalizing denominators. And we're going to get to that a little bit later, where we're going to have to get this guy out of the bottom. Okay, that'll be in the next lesson. Okay, last one here. Okay, use the triangle at the right to find this. So, what is this? Okay, well, you know that this is a fraction. You know that this is which fraction? Okay, coming from cosine. And you know this is what fraction? Coming from tangent, A over O. So then we'll come to over here to our triangle. Here, H. Now, we got to be careful. Hold it up. Can't go ahead and label your O and your A and throw the whole thing in because you get it wrong. Why? Because first they want with A. So if I'm using A, you're O and you're A. So O is 8, H is 10. Oh, here, there's another A. A is 6, and O is 8. But you can't use that now because guess what? You got to flip them around because now you're using angle B. So at angle B, you're O and you're A. So you're going to be using here 10 over 8. So be careful. So if I'm going to neaten this all up, I'm going to rewrite it. I'm going to do 15. Now it says sine A, but I just converted sine A into 8 over 10. Then I'm going to do plus 10, and then it says secant B, but I just turned that into 10 over 8. Then I have, oh no, I was doing so good. No mistakes up until now, I think. Then I have minus 8 cotangent A. I just turned that into 6 over 8. Throw this whole entire thing into your calculator. You're going to end up with 18.5. There you go. So that is an introduction on using the trig ratios. Okay, so in the next lesson, we're going to go ahead and start using angles of rotation, and we're going to get a little bit deeper into some of these questions. Okay, hope the video helped. Pass it along, hit like, comment, subscribe, whatever you guys need and do on this whole YouTube thing.